Advanced Math, Lesson 84, Factorable Expressions and Sketching Sinusoids. So before we start doing factorable expressions, I'm just going to make a really quick comparison that will make these problems make so much more sense. So if we think of sine, or the phrase sine of theta, as our unknown, the same way we would think of x as our unknown, none of our rules of factoring are actually changing. So we're not learning any new rules, we're just applying old rules to new types of numbers, something that seems to be happening a lot. So if we needed to factor this phrase x cubed, what we could do is we could say this is equal to x times x squared, right? Or we could say it's equal to x squared times x. But we can factor an x out of this term. We could even factor 2x out. We can even factor 3x out, right? But when we look at it, we compare it to something like this would be the same. We could do the same thing here. We could say sine cubed of theta is the same as saying sine of theta times sine squared of theta. So you notice we see the split of the exponents. We have 1 and 2 and then 1 and 2. And so same rules of factoring, just new types of numbers being involved with them. Okay, we take the same thing to the difference of squares. So here we have x squared minus 1, both square numbers. The difference of squares would mean that this is going to equal x plus 1 times x minus 1, right? Same thing here. Tangent squared of theta is a square, 1 is a square, so this would factor into tangent of theta plus 1 times tangent of theta minus 1. Difference of two squares. This one, normal trinomial factoring. Okay, so we've got x4, x2, x1. This one, we would just do some, it's also written backwards. Normally our lead coefficient, or it's written in descending order, with our lead coefficient. So to clean this up, I'll go ahead and put x4 minus 2x squared plus 1. That makes it a little bit easier for me to see. So from there I can see that the square root of the first term is going to be the first two terms, so x squared and x squared. Okay. Then the last term is going to be the square root of the last term, so that's going to be 1 and 1. Now the question is about the signs. The signs are different, so they're going to be different, and then the question is which one goes where. Well, they're both going to be negative because they add up to -2. Alright, so that one was successfully factored. Same thing here. I would reverse it all to put it in descending order, so sine 4 of theta. And then if you can factor these without reversing them, that's an amazing skill. Go ahead and use that. But for those of you who don't have that skill, go ahead and put it in descending order. Makes it a little bit easier to read if I can write it. And there we go. Okay, so then the square root of the first one is just going to be sine squared of theta. Very similar to our x squared. So I've got sine squared of theta on both of them. The last term is going to be 1, so I'm going to have 1 and 1. Signs are opposites, so it's going to be negative to get a -2. All right, that is all. Yeah, that's everything we need to cover about old rules that we already know, and then how to apply them to new problems, or new types of numbers. The new problems we're going to get are like our rules of the game problems, where we have to prove that one trig identity is equal to another, and we're going to do that using factoring. So the example that the book gives us is they have the secant to the 4th power of x minus the tangent to the 4th power of x. All of that is over secant squared of x plus tangent squared of x. That's being added to tangent squared of x, and we need to show that all of this is equal to the secant squared of x. So there's a lot of rewriting we need to do. Some of you may have immediately spotted what we can do. We can't really factor this denominator because it's a plus sign, but the numerator has a minus sign, which means we can use difference of two squares. So what's the square root of secant to the 4th power of x? Well, that's just going to be secant squared of x, so that's going to be my lead term. Secant squared of x. My tail term is going to be tangent squared of x, square root of tangent 4x. Okay, and then since it's a difference of two squares, one will be positive, one will be negative. Now remember, this is all the numerator over the denominator of secant squared of x plus tangent squared of x. And you may have noticed something. this parentheses, this one number is the exact same as the denominator. So those two numbers can cancel out. So that and that will cancel. Once those cancel, I'm left with secant squared of x minus tangent squared of x, and then I can't forget about this plus tangent squared of x. So now I have secant squared of x minus tangent squared of x plus tangent squared of x equals secant squared of x. All right, and both of these numbers are just going to cancel. So if you have plus a number then minus a number, they cancel each other out. So then you end up with secant squared of x is equal to secant squared of x. All right, so this is just a different take on problems we've already been doing. We're just going to add factoring into the mix with our trig identities. So that shouldn't be too difficult. The next thing, sketching a sinusoid. I feel like I've accidentally taught you guys how to do this in class. I mean, I was looking at this lesson, I was thinking I feel like we've already learned this before, but in case I haven't made it totally clear, maybe I'm wrong, we're going to learn how to properly sketch the graphs of sinusoids. So our sinusoid function is y is equal to negative 10 plus 2 sine of 3 times x minus 45 degrees. So I believe we have every possible change to this sinusoid that we've learned so far. So in order to graph this, maybe I'll get my graph. Yeah, I'm going to get my graph. We'll graph this here. Okay. I'll leave this right here at the bottom. And we will graph this here. So let's start with the negative 10. All right. So y equals negative 10 plus 2 times sine. The negative 10, if you remember, is going to be our middle line. So our middle line is going to be at negative 10. I've already marked one thing. Okay. And then if you remember, plus 2 is the amplitude, right? So how high it goes up and down. So it's going to go up 2 or down 2. So it's going to be in between negative 10, and if I go up 2 from negative 10, that would be negative 8. If I go down 2, that would be negative 12. Please don't reverse that. That's something that happens often. Some people will go negative 12 up here and negative 8 down here. It's not how it works. Negative 8 is bigger than negative 10. Just don't get confused. Okay, so now that I've got those numbers marked in, then I've got to do sine of 3 times x minus 45 parentheses. Okay, well, first let's start with what should I start with? Should I start with the 3 or the minus 45? Yeah, let's start with the minus 45, okay? So if you remember, phase shifts or shifts left and right on the x-axis are always the opposite of the symbol they're given. So if it says minus 45, I'm actually moving 45 degrees to the right, okay? And then if you remember the general curve of the sinusoid, every 90 degrees it hits the top, the middle, or the bottom, the top, the middle, or the bottom, and then the graph of sine passes through 0 right here at the 0 upward rise. So if it's moving 45 degrees to the right, then hold on, pause. My brain just shut off for me for a second. Hold on. So what's getting me is I'm trying to think. I don't know why my brain just shut off. Do I move the graph to the left and then the thing to the right, or do I move the graph to the right on the thing? Oh, I should just look at the book. The book will tell me. Sometimes I get so caught up that I try to do things entirely under my own ability, and then I forget I have a book to reference that can help me out every now and again. Okay, let's see here. Next from the news. What do they say? Okay, yeah. Wait, that seems so strange to me right now. I feel like the crossing point at 0. It's just slightly off. Yeah, no, okay. All right, so at plus 45, it's going to pass through 0. So Instead of the graph normally passing through 0, I don't know, I apologize for making you guys stare at my paper for so long. That just really got me this morning. So instead of the graph passing through 0 like this, it's going to pass through 45 degrees. So the 0 mark is moved to the right 45 degrees. Wow, that got me really good. Okay. And then we can kind of start drawing our curve. The last thing that we need to get is the phase shift, which is this issue of 3 sine, or 3 times the degrees. So remember, if it's a whole number or a number greater than 1, then we're actually, well, whatever this coefficient is, you just take 360 divided by that coefficient. So if I take 360 and I divide it by 3, I just realized that's on the total edge of this. So if I take 360 and I divide it by 3, I know that's going to be 120 degree period shift. So from here to here is going to be 120 degrees. 120 degrees. And if I break that into 4, that means from here to here is now only 30 degrees. From here to here is only 30, here to here is only 30, here to here is only 30. So this point I know is exactly 45 degrees because that's where my phase shift tells me it is. If I go back 30 degrees right here at 15 degrees, that's where I am. If I go back another 30 at negative 15 degrees, that's where I am. If I go back another 30, that would be negative 45 degrees, and so on and so forth. And then I can also fill out in the opposite direction. If I add 30, that would be positive 75 degrees. Oops. Ugly 75. And then if I add another 30, that's going to be positive 130. Wait, no, 105. I'm not sure what I was thinking there. Okay, but this is how we graph our sinusoid functions. We're just going to deal with every single piece of information. Don't forget on the phase, or the left and right, the lateral shifts, you're moving the sinusoid, not the graph. That's what was getting me. So if it's negative 45, I'm going to move to the right, and the graph is going to move 45 degrees to the right, which means the 0 mark slides over to the 45 degree mark. If you guys have any questions, let me know on Moodle, and I will see you in class.